Hello, everybody. We are here at Kitsap Lake today, the actual lake. It's located about a block away from the school. It is within walking distance to the west. Some of you may even live very near the lake. We are here to test the health of this body of water. This is a natural made lake. It was carved due to a glacier that went through the area a very long time ago. And so we are going to do some testing on the water, some water tests. The lake is currently at a no contact when we were there. However, just a couple days later, order was lifted. And that is why Mr. Johnson is using gloves when he is getting the samples. A few real quick facts about the lake. It's about 240 acres on the surface. Its greatest depth is about 29 feet. On average, it's about 18 to 19 feet deep. And it is a naturally occurring lake carved out by glaciers a long time ago. The water in the lake is replaced every 18 months. And it is a polluted lake oftentimes, and that is due to the sediments that are on the bottom that have been there for a very long time accumulating and things like that. The biggest threat to it right now is stormwater runoff. So all those things that get put on the road, chemicals from cars, chemicals that get put on people's lawns, they all get washed into the lake, and it gathers a bunch of that. The lake has an inlet. It has a stream that empties into the lake, and it has an outlet, and it empties into Kitsap Creek, which then empties to Chico Creek, which then empties into Chico Bay, which is part of Dyes Inlet, which is part of Puget Sound, which is part of the Pacific Ocean. So it's part of that whole watershed that we have surrounding us. So we are going to find out some of the chemical compositions of the lake, what we've got going here, and let's see how it turns out.
Hey guys, I'm here with Mrs. Piper, and we are doing the turbidity test, which is checking how clear our water is. So I am going to, well, I guess I should show you. This is the sucky disc that shows the turbidity, that little thing, and then here is our guide that we use to show how clear our water is. So obviously we want it to be very clear. So I'm gonna scoop some water, and should I set it down? Set it down. It's very green, I've noticed. Here's our chart.
I would say it's not the first one, it's not the 0. I would say the second or the third even.
Yeah, I would say
probably closer to the second one.
I would say it's really close to the 40 JTU in the middle, you guys. Hey guys, we're gonna do a second turbidity test in a different spot at Kitsap Lake. This spot looks very green and algae-like, so let's see what we see here. I did not grab the test, but as you can see, there's no really need for the little strip to go with it. You cannot see it. Yuck. Hey guys, this is the coliform test at Kitsap Lake, and we will see as my shoe gets soaked. A little more water in there. Is it okay if it's a little higher?
Yeah.
Okay. And there we go. And we have to wait 48 hours for this test. So Mrs. Piper will tell you all about it when we find the answers.
So here is the results of the coliform bacteria sample from Kitsap Lake. So this is negative. So it matches with that color. That is not a match, so it goes with this one. So that means if it comes out negative, then that means it does not have coliform bacteria. So what coliform bacteria is it is um, it can come from a variety of things. So it could come from uh, animal waste getting washed into the water. It can come from human waste getting into water. Now you may think, how does that happen? Well, you may have noticed all the houses around there. They are all on a septic system. So what that is great big tanks underground that deal with all the sewage. And if those get old and they start to leak, then that, because of the way the water drains, then it gets washed into the lake and then it gets coliform bacteria. So this is very good that it does not have coliform bacteria. So that is a positive thing because it tested negative. Here are the results of the pH test. So the pH determines if the water is acidic or basic, which is alkaline, or neutral. Water, uh, naturally occurring water, is supposed to be in the range of 6.5 and 8.2. So 7 is about where water naturally occurs on the pH scale. So this would be where we would generally see it. So what we have here, let's compare. So 7 and 8 are both green, and this is definitely green. It looks like 7, it looks like it is probably closer to 8, I would say. Well, I don't know. It's probably somewhere between 7 and 8. So the range was 6.5 to 8.2 for naturally occurring water, and this is definitely in that range. I would say it's somewhere between 7 and 8, maybe a little closer in the 8 range than the 7, but it's where it should be. Now, pH is important for water because there are certain aquatic organisms that adapt to a certain alkalinity in the water, to a certain pH. And so, if there's any disturbance in that pH, then it can have an impact on those organisms who are sensitive to what the pH is. So, it looks like we are good for pH.
All right, guys, we're going to do temperature now over at KLE, or, well, Kitsap Lake. And we'll see what the temperature is here. Let's see what we show here.